Okay, this is physics, NECO, National Examination Council. We have done the objective part, so let's have the theory part today. Part 1 of the theory part that carries 20 marks. So let's start from number 1, 1A. 1AI says, mention a device used for detecting fault in electric circuits. A device used for detecting fault in electric circuit. You can have a multimeter, you can have a continuity tester. A continuity tester can be used, a multimeter can be used. So mention one feature of the named device. Mention one feature of this. When you are using it in electric circuit, when current is in the circuit, when electric current is flowing through the wire or the circuit, a light will be given off. If there is no current in the circuit, light will not be given off, a kind of red light, and that is from LED. Is LED that is giving other lights. So LED is light emitting diode. Okay, it gives out lights. Okay, then we also have it can also give out, multimeter can also give out a kind of a bustling sound. Could be a sound. If there's no fault in a circuit, it will give a bustling sound. If there is fault, it will not give a bustling sound. Okay, we can have that as another feature. Then 1B, distinguish between simple and compound microscopes. A simple microscope makes use of one convex lens, or you call it converging lens, while a compound microscope makes use of two convex lenses. That's one of the differences. Another important difference is this: in a simple microscope, magnification is done once. Magnification is done because it has only one convex lens. Okay, so magnification is done once. Okay, then in a compound microscope, magnification is done twice. Is done 2 times. So magnification is done 2 times. So let's see another difference. The formula for magnification in a compound microscope, in a simple microscope. That simple microscope is also known as magnifying glass. So the formula for magnification in a simple microscope is M equals to V over U. M equals to V over U. So M stands for magnification, V stands for the image distance, U stands for the object distance. Okay. Now, but for a common microscope, the formula for magnification would be capital M equals to small letter 1, substitute 1 times small letter substitute 2. That is, the overall magnification equals to the product of the two magnifications. Magnification M1 is the magnification of the first convex lens, while M2 is the magnification of the second convex lens. Okay, we've differentiated. Okay, then let's see number 1C. 1C is a calculation question. 1C is a calculation question. 1C says that the mass of copper deposited on the cathode of a copper voltmeter. The mass of copper deposited on the cathode of a copper voltmeter is 450 grams. So the mass M, let's look at parameters. M equals to 450 grams. Okay. When a current passed through it for 25 minutes, that means time has been given. Small letter t equals to 25 minutes. Okay. So you calculate the current passed through the voltmeter. Calculate the current passed through the voltmeter. Calculate the current passed through the voltmeter. In bracket, we are given electrochemical equivalent of copper. Electrochemical equivalent of copper is represented by Z. Z equals to, that's Z, equals to 3.3 times 10 raised per minus 4 grams per coulombs. So that is the value that was given. So we're given Z as 3.3 times 10⁴ grams per coulomb. That is the electrochemical equivalent. So we have to find current. Current says calculate the current passed through the voltmeter. That means capital letter I equals to question mark. So the unit of the electrochemical equivalent is gram per coulombs. So since it's in grams, we don't need to convert that mass to grams again. We don't need to convert the mass to kilograms, because at the end of the day, the grams in the mass will cancel the grams in the Z. So we don't need to convert the grams to kilograms again. But there's a need for us to convert the time, which is in minutes, to seconds. So which is in minutes what? To seconds. So how do you convert that? So that would be 25 times 60. Okay, 25 times 60. So when you multiply that, you have 25 times 60. You have 1,500. So we're having 1,500 seconds. So that has been converted. So which formula are we now using? Don't forget that the question is under Faraday's law of electrolysis. Faraday's first law of electrolysis, which states that the mass of an element discharged during electrolysis is directly proportional to the quantity of electricity passing through it. Okay, so mathematically we have the formula as M equals to ZQ. Okay, M equals to ZQ. So let's substitute there. You find that our M is mass is given, Z is given, which is the electrochemical equivalent. Q is not given. You find your Q. But when you get your Q, Q is not the final answer, though that is not what we have to find. So let's substitute. So the mass is 450 equals to Z is 3.3 times 10 raised per minus 4, then times Q. Making Q the subject, what do we get? So we have Q equals to 450 over 3.3 times 10 raised per minus 4. So when you divide that, what do you have? When you divide that, what do you have? We have, so we have 450. Okay, divided by 3.3. So we have it as let me take the standard form. That's 1, 2, 3, 4, 5, 6. 1.36 times 10 raised per 6 times 10 per 6 coulombs. We have 136.364. So let's take the standard form. That's 1, 2, 3, 4, 5, 6. 1.36 times 10 per 6 coulombs. That's not the final answer. So we now use Q equals to IT, or I equals to Q over T. I equals to Q over T. So I is our current, Q is the quantity of charge or quantity of electricity, then T is the time. So substituting, what do you have? So Q is 1.36 times 10 raised per 6 divided by our time. Time is 1,500. So when you divide that, what do you have? Okay, 2 zeros goes there. 2 zeros goes there, remain 4 zeros. So we have 1.36 times 10 raised per 4 divided by 15. So our final answer is, we have, when you divide that, what do you have? Divided by 15. So we have the current as 906.67 amperes. 906.67 amperes. So that is our final answer for number C, 1C. Current says the mass of copper deposited on the cathode of a copper voltammeter is 450 grams when a current passed through it for 25 minutes. Calculate the current passed through the voltammeter. We are given electrochemical equivalent of copper as 3.3 times 10 minus 4 grams per coulombs. Can we now see the next question? I will solve this. The next question, that's number 2. Number 2, we are given a diagram. Let's cut the diagram out. We're having this. We're having this. We're having this. There is a reaction. R is reaction. Then we're having Mg given this way. Mg is given that way. Call this angle alpha. Right. So it said a wooden block was placed on an inclined plane. This is the inclined plane. This is the plane. Are you there? Is inclined to this horizontal. Okay, that's inclined plane. Said a wooden block was, this is the wooden block. This is the wooden block. So we are given this as R. R is a reaction. The upward force acting on the body on the inclined plane. R represents reaction. Are you there? Though they will not tell you is our word. Are you there? Is the physics word. So the physicists know what it represents. Okay. Then we have this as Mg. Mg, mass times acceleration to the gravity. As you know, that Mg is weight. So the weight of the body, weight of every object acts downwards. Weight of any object, any body acts downward. It doesn't act up. Then we are having alpha. We are given alpha as the angle of inclination. Then I said if it is just about to slide, that is if this wooden block along this inclined plane, if it is about to slide, show that the ratio of the sine of angle of alpha, show that the ratio of the sine of angle of alpha to the cosine angle to the cosine of angle alpha is the same as the coefficient of friction. Show that the ratio of the sine of angle alpha to the cosine of angle alpha is the same as the coefficient of friction. Okay, what I'm going to do here, you apply your knowledge of plane geometry in mathematics. Look at this reaction. R is acting upward. You extrapolate it backward, as in this same line, the line of action, you take it backward like this. Okay, when you take it backward, an angle has been formed. Look at the angle the line has formed with the line of Mg. So this angle is also equals to alpha. That's corresponding angles are equal. So this angle also equals to alpha. That's corresponding angles. Okay. So having done that, you find that this Mg, which is acting perpendicularly, which is acting vertically, is a vector quantity. Don't worry, Mg is weight. Mg is weight, a vector quantity. Are you there? So it can be resolved. This Mg will resolve vertically. This is the vertical component, and horizontally, this is the horizontal component. This is the horizontal point in this direction. Or you say, can you see I form a right angle here? Or a quadrant. Okay? So this Mg is in between this and this. It means that this Mg will be resolved vertically and what? Horizontally. It will have a vertical component and horizontal component. One will be sine alpha, the other one will be cos alpha. So the vertical component here would be Mg cos alpha, mg cos alpha, while the horizontal component will be mg sine alpha. Okay, why? Because the angle alpha is with the vertical. If this angle alpha, if this here, this one that is mg sine alpha will become mg cos alpha. This one that is mg cos alpha will be mg sine alpha. It depends. You get the same answer because sine 30 and cos 60 they are the same thing. Sine 30 is 0.5, cos 60 is 0.5. So if you have the angle in this particular direction, as in with the vertical here, this vertical component will be mg cos alpha, while horizontal component will be mg sine alpha. But if the angle is here, we say it is with horizontal. Are you there? This mg sine alpha become mg cos alpha, while this mg cos alpha become mg sine alpha. So having done that, oh, don't forget in the I omitted force. We are given F here, capital F, acting upward along the plane. So that is the force. We are given force in the diagram there. Okay, that is the force. That is the force that is pushing the body upward. Okay. Can we now have our solution? Haven't done that. You can see that there are 4 forces now acting on the body. 4 forces. One force is R acting upward. Another force is mg cos alpha acting downward. One force is F acting to the left, to the right hand side. Another force is mg sine alpha to the left hand side. So we have to combine the horizontal forces together, the left and right forces. How do you do that? We sum them up. Summation F sub S equals to, that is summation, that is addition of left and right forces. So go back to your maths. You have this plus y, this minus y, right hand side is plus s, left hand side minus s. So any force or any vector that is pointing in the plus s direction of your graph, you give it plus. While the one that is pointing in the minus s direction, you give it minus. Look at this F, it's pointing in the plus s direction. So that will be F. So plus is there, invisible plus is there mathematically. Don't forget we are summing it up. Plus. Now, another force, the left hand side force. Don't forget that summation F sub S means addition of left and right forces. Then we are having mg sine alpha. Mg sine alpha is pointing in the negative s direction. So that will be minus, bracket, minus mg sine alpha. Okay. So around there we have it as summation F sub S equals to F plus times minus minus mg sine alpha. Okay. Don't forget that they said if it is just about to slide, that means the body, this building block, is in equilibrium. So when the body is in equilibrium, the sum of the forces acting on it is 0. Okay. So this much F of S will now be equated to 0. That is F minus mg sine alpha will now say it is equal to 0 because the body is in equilibrium. So F minus mg sine alpha equals to 0. Why? Because the body is not moving yet. So making F the subject, now have F equals to mg sine alpha. So we have gotten force. Let's leave down. Let that one be resting there. We'll come back to that later. That is summation of left and right forces. Let's now go to summation of up and down forces. Just the same thing. Summation of up and down forces. So that will be summation F subscript y equals to, that is summation of up and down forces. Summation of up and down forces. R reaction is acting upward. Any force that is acting, or any vector that is acting upward in the plus y direction in your graph will take plus, while the one that's acting downward, which is in the minus y direction, will take minus. Okay, so R is acting upward, that is R, plus, that plus is coming because we are saying summation F of y, right there. Then mg cos alpha is acting downward, that is minus mg cos alpha. Okay, so the same thing, the body is in equilibrium, the wooden block is in equilibrium, so we equate to 0. So our r plus times minus r minus mg cos alpha will now be equals to 0. So from there, make r the subject. We have r equals to mg cos alpha. All right. What is now the formula for friction? What's the formula for friction? Formula of friction is we have F subscript r equals to mu r. F subscript r, that is frictional force, equals to mu r. Okay, the mu is the coefficient of friction. The mu is the coefficient of friction. While r is the reaction. Okay, so the Fr, which is the frictional force, is same thing as the force we have gotten here. The frictional force is equal to the force we have gotten here, the mg sin alpha that we've gotten here. We can substitute. Our Fr is not our F, so let's substitute. So Fr is mg sin alpha equals to mu. So that mu is the coefficient of friction that we are looking for. So multiply by our r. We have gotten our r as mg cos alpha. So can we now make the mu as the subject of the formula? When you make mu the subject of the formula, what do you have? So you have a mu equals to mg sin alpha over mg cos alpha. Mg cancel mg. We are left with mu equals to sin alpha over cos alpha. In trigonometry, sin theta over cos theta is tan theta. So sin alpha over cos alpha is tan alpha. That's tan alpha. So that is the final answer. So this is the coefficient of friction. That's the coefficient of friction. The question says that show that the ratio of the sine of angle alpha. So we can even stop here. We even ask to stop here. That's mu equals to sine alpha over cos alpha. They have gone beyond that self. It says show that the ratio of sine of angle alpha, which is this, to the cosine of angle alpha is the same as the coefficient of friction. That has been done. Alright, let's go to number 3a. 3a says, what is the range of a projectile? What is the range of a projectile? What is the range of a projectile? Okay, the range of a projectile is the horizontal distance. Is what? The horizontal distance between the point at which the body was projected to the point at which it landed. Range is the horizontal distance between the point at which the body was projected to the point at which it landed on the same horizontal plane. So what I say necessarily is this: if you fire a bullet from a gun, the bullet goes this way and comes down. It forms a parabolic path. If you throw a javelin, it goes this way like this, forms a parabolic path. If you kick a ball, if you kick a ball, the ball goes this way. So in this particular format, if this is the origin the ball will go this way and come down. Okay, if you project it, if you join these parts together, we have this, and this is the initial velocity with which the body was projected. Okay, the initial velocity with which the body was projected. So this is the maximum height attained by the body in the air or in space. Okay, now this point and this point is range. The point at which the body started to the point at which it landed, that is the range, capital letter R. So range, we say range is also horizontal distance between the point at which the body was projected to the point at which it landed on the same horizontal plane. That is range. You say what is range? Okay, then that's 3A. 3B says an athlete threw a javelin with a velocity of 12 meters per second. An athlete threw a javelin with a velocity of 12 meters per second. That is U. That means initial velocity has been given. U equals to 12 meters per second. Okay. Now said if the javelin hits the ground after 1.5 seconds. You see, it said if the javelin hits the ground after 1.5 seconds, that means the javelin went into the air and came back to the ground. It went into the air, it spent a particular time, then it came down to the ground. That's another time. The time it takes to go up is the same as the time it takes to come down. If it takes 3 seconds to go up, it will also take 3 seconds to come down. So 3 plus 3 becomes 6. So how do we say that? We call it in projectile as a topic in physics, we call it time of flight. Time of flight. That is the total time spent by the body in air. Time of flight. Okay, so the total time taken by the body to go into air and come back to the ground, that is time of flight. So this T, they say if the javelin hits the ground after 1.5 seconds, so it is not small letter t, but it is what? Capital letter T, which is what? Time of flight. Okay, that's the difference. So time of flight said if the javelin hits the ground after 1.5 seconds. So our capital letter T is 1.5 seconds. That's time of flight. Then we're given G. They said an athlete threw a javelin with a velocity of 12 meters per second. If the javelin hits the ground after 1.5 seconds, calculate its angle of projection. We are given G, acceleration due to gravity, small letter G, as 10 meters per second square. So we are looking for theta, question mark. Looking for theta, that's question mark. An athlete threw a javelin with a velocity of 12 meters per second. If the javelin hits the ground after 1.5 seconds, calculate its angle of projection. So we are using the formula for time of flight. And what is the formula for time of flight? The formula for time of flight is capital letter T equals to 2u sine theta over g. 2u sine theta over g. Okay, that is time of flight. But some students will go and use T, small letter T equals to u sine theta over g, which is wrong. And something like that, you get a wrong answer. Okay, so capital T equals to 2u sine theta over g. Now let's substitute. A capital T, which is a time of flight, is 1.5 equals to 2 multiplied by u is 12, then sine theta. We're looking for that. All over g, 10. So when you multiply and make sine theta the subject, you have sine theta equals to 1.5 times 10 over 2 times 12. So sine theta equals to 15, 1.5 times 10, 15 over 2 times 12, 24. So sine theta will give you 15 divided by 24 So 15 divided by 24, that gives us 0.625. That's 0.625. Making theta the subject. So theta equals to second function or arc sine 0.625 with a calculator. Arc sine or second function of 0.625, shift sine 0.625. That is giving me 38.68. 38.68. So that's 38.68 degrees. That's the angle of projection. Angle of projection, 38.68 degrees. That's the answer to number 3B. Now 4A. Mention two bodies possessing kinetic energy. Mention two bodies possessing kinetic energy. First and foremost, before you can give two bodies possessing kinetic energy, you have to know what kinetic energy is. Kinetic energy is the energy possessed by a body in motion. The energy possessed by a body in what? In motion. So you give examples of bodies that are in motion. Are you there? So we have a lot of them out there. A lot of them that you can think of. Okay, you can say number one, a flying airplane. A flying airplane. You don't just write airplane. They give you beautiful zero there. A flying airplane. That's one. You can say rotation of the blades of a ceiling fan. You don't just say ceiling fan, but rotation of the blades of a ceiling fan. That's another example. Then you can also say a fired bullet from a gun. A fired bullet. A fired bullet from a gun. You can also say a falling mango from a mango tree. You know, a lot of examples are there. Okay, as they say, mention two bodies possessing kinetic energy. Okay, you can also say an insect flying from one flower to another. Let's go to number 4B. Number 4B, that is a calculation question. That's a calculation question. All right. A waterfall is 108 meters high. A waterfall is 108 meters high. Calculate the difference in temperature of the water above and below the waterfall. A waterfall is 108 meters high. Calculate the difference in temperature of the waterfall and below the waterfall. You know, as a physics student, you should know that this question is under its capacity, its measurements. So let's add the parameters as usual, which is our norm in physics. Okay, a waterfall is 108 meters high. That means height has been given. H equals to 108 meters. Okay. And they said calculate the difference in temperature of the water above and below the waterfall. Difference in temperature, that's change in theta. The symbol change in theta. Delta theta equals to question mark. And don't forget that we are equally given G. They give us G, which is acceleration due to gravity. That is G equals to 10 meters per second squared. Oh, we are given height, we are given G. We have to find the change in temperature, which is delta theta. You know, you now begin to reason in exam hall that temperature has to do with heat. Okay, height. In most cases in physics, when you see height, height is a function of potential energy. Height is related to potential energy. then velocity is related to kinetic energy. Are we together? Okay. So that means they are telling you to relate the formula of potential energy to what? Heat energy. Don't forget, according to the law of conservation of energy, which we call the first law of thermodynamics. Are you there? That energy cannot be created nor destroyed, but can be transferred from one form to another. Here we are converting the potential energy into what? Heat energy. So let's say heat energy, the heat energy is equals to the potential energy. Okay, so what was the formula for the heat energy that we're going to use here? So we use MC change in theta. Capital H equals to MC change in theta. So MC change in theta, MC change in theta, that's the formula. So equals to formula for potential energy, mgh. Okay, some students will be like, how can I get my mass? How can I get my mass? So you can see on both sides that mass has cancelled out. MC change in theta equals to mgh equals to mgh. So you find that mass can cancel out on both sides. So mass cancel out on both sides. Okay, so we are left with C change in theta equals to gh. Okay, C change in theta equals to gh. What does C represent? C is a specific heat capacity of water. Then we're looking for change in theta, right? So as you can see in the question, we are not given the constant C, which is a specific heat capacity. So you can leave your answer in terms of C, and you can as well say taking or assuming that C is 4,200 joules per kilogram per Kelvin is a constant. So let us get our answers in terms of C first. So C change in theta equals to G is 10, and then height is 108. At the end of the day, we have change in theta equals to 1080. That is 10 times 108. Okay, divided by C. So degree Celsius. That's the final answer. So change in theta equals to 1080 over C, degree Celsius. That's the final answer, since you are not given the specific heat capacity of water. But if you can stop here, and you can as well, another person can as well continue and say, okay, assuming that C is 4,200 joules per kilogram per Kelvin. Okay, so if you want to do that, then you can now change in theta equals to 1080 all over 4,200. When you divide that, what do you have? 1080 divided by 4,200. You have it as 0.26 approx. 0.26 approx. So it's 0.26 degrees Celsius. So that's the final answer. That's the change in temperature between the water above and water below in the waterfall. So let's look at number 5. What does number 5 say? Number 5 says, what is vaporization? What is vaporization? Okay. Vaporization is the process. That is number 5A. Vaporization is a process by which a liquid changes into a gaseous state. Is the process by which a liquid changes into a gaseous state or changes into vapor. Are you there? Vaporization is the process by which a liquid changes into a gaseous state or changes into vapor, or changes into vapor, or changes into vapor. Okay. Without change in temperature. 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 Okay. All right. So let's have 5B. 5B says states one effect of increase. So you know what? Let's stop at 5A. So after 5A we'll continue. Okay. We'll term this on part A, part 1. Then when we continue, we turn down on part 2. Is that taken? So let's we start at 5A. We'll continue in part 2 as 5B.